Good evening, students. My name is Jay Surya, and today's session will be on quadratic equations and their solutions or roots. First, let us see what is a polynomial. A polynomial consists of one or more terms, and each term will have a constant and it will have a variable raised to an exponent. Raised to an exponent. That is, for example, a constant could be 3. The variable typically would be x and the exponent could be 3. So like this, we can link many terms together to form the polynomial. For example, 1 plus x plus 2x squared plus 3x cubed would be a polynomial of 4 terms. The variable here, the independent variable is x, and the power of x are the 0, 1, x to the power of 0 is 1, so the power of x here is 0, power of x is 1, power of x is 2, power of x is 3. The coefficients are 1, 1, 2, and 3 respectively. The coefficients can be any rational or irrational number. It can be real, typically. But the exponent of the variable has to be a non-zero integer. That means it can be anything from 1, 2, 3, etc. For example, if I write 2 plus x to the power of half, this is not a polynomial because the x has been raised to the exponent half, which is not a non-zero integer. Similarly, 3 minus x to the power of minus 1 plus x squared is also not a polynomial expression because you're raising this to the power of minus 1, which is a negative integer. So basically, we have to use integer exponents, and the coefficient can be real, it can be imaginary also. But we are not going to deal with that. And there can be any number of terms which the polynomial can have. Now let us go to a special class of polynomial, which is the quadratic expression. What is a quadratic expression or quadratic polynomial? A quadratic polynomial is one where the degree of the expression is 2. For example, 3x squared plus 2x plus 1 is a quadratic expression because the highest exponent of x here is 2. So degree of this expression is 2, which is the highest exponent which it has. For example, 5x cubed plus 7x squared plus 8 has a degree 3, this polynomial. It's not a quadratic, this is a cubic polynomial. This has a degree 3. Okay. So all quadratic polynomials have a degree 2. That means there must be a sort of x squared term present. Now, uh, now 3x squared plus 1 is also a quadratic, although there are only two terms, because the degree of this expression is 2. It's a quadratic. On the other hand, if I have 2x plus 1 is not a quadratic because the degree of this expression is 1 and it's a linear expression and not a quadratic expression. So a quadratic expression has a degree 2. Typically, a quadratic expression would have the form ax squared plus bx plus c. A is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant. Now, let me just put aside here. I need not use x. I can use any other variable. I can say 3y squared plus 5y plus 2, etc. I can use any variable. Not only that, a polynomial will permit you to use multiple variables. But in a quadratic, there's going to be only one variable, right? In a quadratic, there's going to be one variable which is going to be raised to the power of 2 and possibly 1 and a constant. Now, ax squared plus bx plus c is a quadratic expression. Now, let us take an example of this. Let us say 2x squared plus x plus 1 is obviously a quadratic expression. The quadratic expression. Now, typically, what we do is x is called the independent variable because you can tell you to any value you want, and the dependent variable would be termed as y is equal to x squared plus x plus 1. So y will take different values depending upon the value of x you give here. Or we can also write as f of x. Function of x is equal to y is equal to 2x squared plus x plus 1. What it means really is that if I take the xy axis, if I take the xy axis, x and y axis, if I take a value of x, let's say 1, I, I substitute this in this expression. So 2 into 1 squared plus 1 plus 1 which is equal to 4, right? So the value of y is 4. So corresponding to 1, I plot 4. This is 4. Then I take another value, say x is equal to 2. So 2 into 2 squared plus 2 plus 1 would be 2, 4 into 8, 10, 11. So when x is equal to 2, y is equal to, let's say here, it's 8, 12, say 11 here, 11 here, 2, 11. So basically, I am able to plot this expression for different values of x. So we get for different values of x, what is the value of this expression which we are considering? This 2x squared plus x plus 1 or whatever expression we want, we can substitute the values of x and plot on the xy plane the value of y for each and every value of x and then get a corresponding graph. So this graph of the expression y is equal to x squared plus x plus 1 basically gives you the value of y you can find for any value of x. If you take x equal to 5, you can find what is the value of the expression. If you take x equal to 10, you can find the value of the expression. So that is the graph of the expression, right? Okay, fine. Now let's consider something else. When let me take slightly simple. But let's say I'll take a slightly simpler function. X squared plus 2x plus 1 is a quadratic expression. So here y is equal to this. Now if I equate to 0, x squared plus 2x plus 1 equal to 0, what does it mean? X squared plus 2x plus 1 basically is some curve like this, right? Be some curve like this, whatever. You can draw the curve. You can find the curve and draw it. But what is x squared plus x plus 1 is equal to 0? Now it's become an equation, right? Left hand side, right hand side has become an equation. So what does this mean? This means that there are some values of x which when substituted into the left hand side will give you 0. That means the expression will become 0 for certain values of x. And with values of x for which the expression becomes 0 are called the roots of the equation, or also called the solution to the equation. Right? So basically, we have to find. So when I say values equal to 0, what does it mean? It means, taking another curve, it means where the expression cuts the x-axis. These are the solutions of the roots of the equation. Because where it cuts the x-axis, y value will be 0. So wherever the expression cuts the x-axis, you will find the solution of the equation corresponding to the expression, whatever, is equal to 0. Now, if you want to find out what are the values of x for which this expression x squared plus 2x plus 1 would be 0, one way of doing it would be to factorize it. So you have x squared plus 2x plus 1 equal to 0. I need to factorize this. That means make it into two factors. I'll come later into why this factorization is required. Okay. I'll, I'll treat it now. If I can factorize this expression into, say, x minus some whatever, x minus p1, some value, if I can factorize this equation into x minus p1 to x minus p2, then I can equate x minus p1 to x minus p2 equals 0, right? When will the right hand side be 0? Either when x minus p1 is equal to 0 or x minus p2 is equal to 0. If x minus p1 is equal to 0, x will be equal to p1. If x plus p2 is 0, x will be equal to p2. That means for any value p1 or p2 which you obtain from factorizing the expression, the value of the expression x squared plus 2x plus 1 will be 0. In other words, this p1 and p2 will be the place where the expression, the value of y will cut or touch the x-axis. It can either cut the x-axis or touch the x-axis. So basically, it either cuts the x-axis or touches the x-axis. But let's see now when it will cut and when it will touch. We need to factorize x squared plus 2x plus 1, right? Now, in order to find the factor, first and foremost, basically, this is a constant, right? So constant, so typically, if I have a factor ax squared plus bx plus c, then I will take a and c and multiply a into c and find the five factors of a and c. And then see if the factors can add or subtract to give b. Okay, let me illustrate. I've got x squared plus 2x plus 1. A is 1. B is 2, C is 1, right? A x squared plus bx plus c. Right? Okay. Now, A is 1 and C is 1. So I've got only 1. A into C is 1, right? Now, how do I how do I break it up into two factors? The only way I can do it is making 1 and 1. 1 would be equal to 1 into 1. That's all one can do. Nothing much, actually, unless you go into fractions. So 1 is equal to 1 to 1. If you go 1 to 1, this component plus this component will give you 2. 1 plus 1, 2. So I have broken up this AC into two components which add up to the middle coefficient B. So now I can factorize. I put a x squared plus one component is 1. So x, other component is 1. Again another x plus 1, which is equal to, or x into x plus 1 plus 1 into x plus 1. I'm just factorizing the left hand side, or this is equal to, or x plus 1 into x plus 1. And now I'll bring the right hand side equal to 0. Now x plus 1 to x plus 1 equal to 0 is also means x plus 1 squared is equal to 0, right? So when will x plus 1 squared be 0? For what value of x? When x plus 1 is equal to 0 or x is equal to minus 1. So we can say that there are two roots which are equal and the same value as of the value minus 1. So we have two roots of the same identical of minus 1. So now if we draw the graph of x squared plus x plus 2x, x squared plus 2x plus 1, we take here x equal to minus 1. Since both as I already told you, which I'll explain later, uh, that if A is 1, it opens upwards, right? If A is 1, the curve opens upwards. So it will touch the x-axis like here at x equal to 1 and open upwards. This is the parabolic x equal to minus 1. This is the parabolic curve corresponding to x squared plus 2x plus 1. I have factorized it, found the roots, and depicted the roots where it cuts the x-axis. In this case, it touches the x-axis, and then I can draw the curve. I'll have a rough idea of how the curve looks like. Now, this was one case. Let me go to another. Let's take another expression. X squared plus 5x plus 6. We want to factorize it. And then, of course, equal to 0. Once we factorize it, we can find the roots. Now, x squared plus 5 is 6. A is equal to, A is 1. A is 1. B is 5, right? C is 6. So, AC will be 6. Now, how many ways can I write the factors of 6? I can say 1 into 6 or 2 into 3, right? That's all. 1 into 6 or 2 into 3. 1 to 6 will work out. Now, one thing you should note here, if the sign of the C coefficient is plus, if the C coefficient is plus, then the two terms will be, two components will be either positive or negative, not vice versa, not one positive, one negative. If C is minus, then one will be positive, another negative. That means if C is positive, the two terms will add up. Either the difference will add up or the sum will add up, right? The positive will add up. So here, I can't have 1 and 1 minus 6 because they need to add up. So although 1 minus 6, 6 minus 1 gives you 5, that won't be the solution. Because since AC is positive, it should add up. So what about 2 and 3? 2 plus 3 is 5. Fine. So what I can do is now I break up the 5x into x squared plus 2x plus 3x plus 6. Okay, I put 0 here. Then I factorize x into x plus 2 plus 3 into x plus 2 is equal to 0. Or x plus 2 into x plus 3 is equal to 0. Or x is equal to minus 2. Because x plus 2 is 0 means x minus 2. Or x plus 3 is 0 means or minus 3. So x is equal to minus 2 or minus 3. Then if I plot, write it here, so minus 2 will be here, minus 3 will be here. So this curve, this x squared plus 5 plus 6 expression, the roots are at minus 2 and minus 3. Here, minus 2 and minus 3. I put the x mark on the x-axis. And now, since a is positive, it will go like this. Similarly, we can factorize uh, expressions which have, for example, let me give you one example here. X squared mm, minus 2 plus x. X squared plus x minus 2 equal to 0. So A is 1, C is, so root is minus 2, right? So you can, if you want to take, you can take minus 2 or whatever. 2 factors of 1 are 2 and 1. So now, since it's minus, they will subtract. So I can say 2 minus 1 will be equal to 1b. Then b. 2 minus 1 will be 1. So I can write x squared plus 2x minus x minus 2 is equal to 0. 2x minus x is equal to x. Must be equal to x. Right? The two components, it is 2x and x. So the difference of them should be equal to the middle term. And since minus, there will be a difference, not addition. Now I can factorize into x plus 2 minus 1 into x plus 2 equal to 0, or x plus 2 into x minus 1 equal to 0. So the roots of the equation are minus 2 and 1, correspond to x plus 2 to 0, or x minus 1 equal to 0. That means it will be basically minus 2 or 1. And again, A is positive, so it's going to be like this. So finally, we consider why, if A is positive, you get a U curve, and when A is negative, you get a reverse U. Let us consider that. Just take a simple equation, x minus 2 into x minus 3 is equal to 0. So obviously, you know, the roots are 2 and 3, right? Correspond to x minus 2 equal to 0 and x minus 3 equal to 0. X minus 2 equal to 0. So x is equal to 2. X minus 3 equal to 0. So x is equal to 3. So 2 and 3. So immediately I can plot my x and y axis and draw 2 and 3. 2, 3. The zeros or the roots. Now, if I have a value, if any value x is less than 2, for example, 1.5, what will happen to this? 1.5 minus 2 will be negative. X 1.5 minus 3 will also be negative. Correct? Negative, negative will be positive. So for any value less than 2, the expression is going to be, function is going to be positive. Similarly, if you take any value greater than 3, x minus 2 into x minus 3 greater than say 3.5 will be positive. 3.5 positive, 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 positive. So again, after beyond 3 is positive. What about between 2 and 3? Between 2 and 3, what will happen is, if it is 2.5, this is going to be positive, 2.5 minus 2, 2.5 minus 2, and 2.5 minus 3 will be negative. So positive, negative is negative. So the value of the expression of function will be below the x-axis. And so we have a curve which is U-shaped facing upward. So for any roots for which A is positive, always the curve will be facing upwards. And the roots obviously, when they are real, will be on the x-axis. And if the roots are equal, they'll be touching like this. Right? If the roots are equal, they'll be touching the x-axis. They could be touching the y-axis like this also. If A is negative, this will touch here with the downward, with the inverse U. A A is negative, it could touch here with as an inverse U. A positive means it will be a uh, upward facing U when both the roots are equal. And on the treatise on determining whether A is negative, right? If A is negative, then we have minus 3x squared. So let's not take this. See, we have minus x squared minus 2x plus 2x plus minus 1. So this expression A is negative. So it is equal to minus of x squared minus 2x plus 1. Right? So this is nothing but minus of x minus 1 whole squared. So the roots are at 1 and there are two roots, right? Now the thing is whether is it going to point upwards or downwards? So for any value of x minus 1 squared is on, for let's say 2 or 2.5 or minus 2, x minus 1 squared will always be positive for any value of x because it's square. So negative or square will be negative. So that means always for this function where a is negative, the curve u will be shaped downwards. And one more point I'd like to make quickly, that if you have a quadratic equation ax squared plus bx plus c equal to 0, we can derive, but for now we take it for granted, that each root is equal to x is equal to minus b plus or minus root of b squared minus 4ac by 2a. Okay. So we can substitute the values of a and b and find the roots. Now the question is, what happens if b squared is equal to 4ac? In the particular equation we have taken, if b squared is equal to 4ac, then what will happen? If b squared is equal to 4ac, then this component will be 0. If this component is 0, then there will be only one root, minus b by 2a. So it will be just like your x minus 1 squared. If you say x minus 1 squared, you take this x squared minus 2x plus 1, right? And what is the value of b? B is minus 2. B squared is 4 plus 4 minus 4 into 1 into 1, 4. 4ac is 1. So this is 4ac. This is b squared. So b squared 4 is 0. Therefore, this part disappears. So both the roots are going to be minus b by 2a. That is minus b. That is minus 2 by 2, which is equal to 1. So both the roots will be 1. That is, if b square minus 4ac is equal to 0. If b square minus 4 is positive, then we get two different roots, right? But if b squared minus 4ac is negative, what happens? If it's negative, then square root of a negative value is going to be an imaginary value, right? So the roots are imaginary now, not real. What do you mean roots are imaginary? It only means one thing, that no longer will the function or the expression have roots cutting the x-axis. No, it will be somewhere like this. This expression will not have any intersection with the x-axis if the discriminant, as we call it, b squared minus 4ac, is imaginary. Only if it is 0 or positive, the roots will cut the x-axis. If b square minus 4ac is imaginary, the roots will no longer cut the x-axis, and the roots are called imaginary roots. Imaginary roots of the function. So this then was quadratic equations, and basically I have tried to orient it from the graphical angle. What is the expression? How do we graph an expression? What happens when you equate the expression to zero? Basically, zero crossing points are the solutions of the equation. What is the quadratic equation, right? And what happens if the quadratic, both the roots of the quadratic equation are equal? How does the graph look like? What if they are different? How will the curve look? If it's point upwards or downwards? And lastly, what happens when the curve does not touch the x-axis or cut the x-axis at all? They're imaginary. So b square minus 4ac will be negative. So I hope you have been able to follow what I've said. Thank you very much for your kind attention. Thank you.